Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson for our engineering economics, we're going to be looking at how we can compare large projects using incremental analysis. We will specifically be looking at how we can compare mutually exclusive projects. The idea being that if you can only choose one or none of the possible projects, then the projects will be considered mutually exclusive. Sometimes we have that you can do multiple projects and you can build combinations that still meet your criterion and test each of those as if, like, you could do A alone or B alone, or you could do A plus B together and treat each of those combinations as a mutually exclusive option and still use this technique. Now, we can make our selections based on any of our financial criterion, but typically net present value and rate of return are used, and they should interchangeably give us the same result. So let's look at how we can use these techniques to make the best choice. So if we consider that we are in charge of $120 million that could be spent for a new project, and I have three proposals in front of me. One, I would only have to spend $60 million, one $120 million, and one $100 million, and the after-tax cash flows will vary for the various projects. We're going to assume that my company requires a minimum acceptable rate of return of 10%. And that I'm basing this on a 10-year plant operating project. I'm going to, for the sake of simplicity, ignore salvage value and return of working capital and land at the end of the project. That just complicates things unnecessarily for this stage. Now, if we do this and we figure out the net present value and the discounted cash flow rate of return for each of these projects, using the formulas here, this is a screenshot from the textbook. We find that Project A only earns $12 million, B $15 million, and Project C will earn $15.6 million. So clearly Project C looks like the winner, right? But if I do rate of return analysis, Project A earns 14.35%, B only 12.87%, and C earns 13.34%. So A has the highest rate of return, so maybe that's the winner. And the point is, it shouldn't matter which one of these financial analysis tools we use. I ought to get a clear-cut answer that's the same, regardless of technique. And the point is, I'm spending different amounts of money for each one. So what we want to do is we want to look at incremental analysis. So incremental analysis starts with just pick the cheapest, okay, the lowest capital investment, which in this case is Project A, and look at the net present value. Is it positive? Great. Then let's consider this to be my possible winner. We're going to then move and consider the next more expensive. In this case, Project C was $100 million. Was spending that extra $40 million worth it? So let's look at the incremental investment, that $40 million, and the incremental cash flows, and do the net present value on this incremental spending. In this case, I get $3.7 million is my incremental net present value earned on that extra $40 million. That's positive, so I'm still happy with this. Spending this extra money looks good. If I had chosen to use rate of return, I get 11.9%. That's greater than 10%. So again, I'm happy with this as my choice. So Project C looks like it's better than Project A. And then I should go on through the list. So my next choice, the next most expensive, is Project B at $120 million. Now, Project C is my best now. So I compared C to A, and C won. So now that I'm going to compare B to C. So I'm going to spend an extra 20 million. And my cash flows give me a negative net present value. That extra 20 million spent loses money. The discounted cash flow rate of return earns a 9.4% rate of return, which is less than the 10% which we set as our minimum standard. Therefore, option B is not a good use of additional funds. So project C becomes the clear winner in this case. So this is an introduction to incremental analysis. Next, we're going to be looking at some smaller kinds of concerns, such as just a comparison of purchasing various equipment. So thank you very much for your time.